Okay, welcome to chemistry week 2, week 4 CA. You can see for yourself that I, you can see for yourself. I'm not gonna say anything. Okay, by the amount of mistakes I got. Which of the following which of the following chemicals may produce sulfur dioxide gas when mixed together and warmed? Me personally, I wasn't taught this in class. Okay, what my teacher taught me was what's in this notes, and what's in this notes. Maybe 3 questions out of these 22 came from the notes. So I actually had to open the book and start like reading like, okay, so you can memorize it. It's they said there are 2 ways sulfur dioxide is prepared. There's industrially and there is in the lab. Okay, it's here. 1 second. Um, Hold up, guys. Here, yeah. So in the lab, you mix sodium sulfide, sulfur, whatever. Yeah, yeah. So sulfur dioxide can be prepared in the lab by the action of dilute acids on sulfides. This is a sulfite. Okay, any compound that has a metal with like sulfur is a sulfide. Okay, and mix with an acid. So just mix it with an acid, and that's how you prepare, and you get at the end SO2, sulfur dioxide. So sulfur dioxide, okay, we can get it when mixed together. Yeah, when you mix a sulfite with an acid. Okay, طب وليد it said HCl not HNO3. Man, this HNO3 is also an acid. Okay, uh, nitric acid. It stands for nitric acid. Okay, these are all they're not sulfites. So hey, question 2. How is sulfur dioxide manufactured? Now, this is manufactured يعني industrial. Industrial في 3 ways, okay? In the book. In the notes, it says otherwise, okay? In the notes, it says sulfur dioxide is obtained by burning sulfur or roasting sulfide ores, okay? And you mix it with oxygen to get sulfur dioxide. Oxygen is obtained from whatever, okay? So there are 2 ways in the book, as in the notes, they say this, okay? And you can also roast sulfide ores, any sulfide, a metal sulfide, okay? So for example, the metal sulfides, like iron sulfide, iron sulfate, okay, these are all metal sulfides, okay? But if you burn them with air, or when you burn them, they react with oxygen to form SO2. Here also burning sulfur in air. That's also correct. We're burning it in air, right? Question melting, no. Mixing sulfur and oxygen at a low temperature, لا. Low temperature, it won't burn. Which of the following are NPK fertilizers? Okay, the NPK fertilizers, it stands for nitrogen, okay, phosphorus, okay, and K is potassium. I'm sure you guys know that the symbol for potassium is K, okay. Nitrogen, phosphorus, potassium. Is it this one? No, there's no nitrogen, there's no phosphorus, there's no potassium. Here there's potassium. Here there's ammonium phosphate. Okay. Here it's ammonium chloride. Ammonium chloride is not, it's not a fertilizer. You can see here in the notes for nitrogen. Yeah, here the 3 examples: ammonium nitrate NH4 NH4NO3, sorry, or ammonium phosphate NH4PO3, as the PO4. Okay, phosphorus, whatever, potassium, whatever. Uh, Question 4. Which of the following are true about fertilizers? Okay, sorry, back here, NH4Cl isn't part of these. Okay, that's why we didn't pick it. Which of the following is the question 4? Which of the following are true about fertilizers? Fertilizers can lead to eutrophication of lakes. This is biology. Fertilizers supply the plants with the needed nutrients to grow faster. Akid, correct. Okay, fertilizers are sold in solid or liquid. That's correct. Solid could be feces of either plants or dead people. Okay, because when we decompose, we give off nitrogen, and nitrogen is a very good fertilizer. And it may be a liquid form, something you can pour. Does it have a rapid effect? No. Okay. It makes a difference. It's like a catalyst, but it's not rapid. يعني it's مش هيك بسرعة. Eutrophication, for those who do bio, you should know that eutrophication, they ask this question a lot, for those who do bio. You took it in year 1, I think, biology. Eutrophication is when fertilizer is added to a pond or a lake, okay, and it causes the plants in the lake to grow, okay, the aquatic plants. Those aquatic plants, they're gonna grow, and they're gonna grow a lot, right? Because there's fertilizer, it's gonna grow a lot. So they're gonna grow a lot and become bigger and become larger, and they're gonna photosynthesize using photosynthesis. Okay, after they photosynthesize, they're gonna keep on growing and growing larger, and they're gonna start blocking sunlight for the fish. They're gonna start blocking the sunlight. Like imagine you have a pond, all the plants they're growing now from down. So now they're blocking the sunlight for all these plants down. So since there's sunlight being blocked, there's going to be a lot of plants who are going to die now. And when those plants die, they decompose, releasing carbon dioxide, and they release carbon dioxide and they absorb oxygen. So there's going to be less oxygen in the water, and therefore the fish in the water will start dying. This is the process of eutrophication. Okay, it leads to the death of fish. Question 5. Which of the following are pollutants produced by a car engine? Just memorize this, guys. Nitrogen monoxide, carbon monoxide. Like أنا ما بعرف شو ألكم والله. Just memorize. All this quiz is memorizing. Okay. Uh, Ammonia NH3 is produced industrially. Okay, in the Haber process. Okay, the Haber process. This is actually in the notes, like somewhere. Okay. Yeah, the Haber process. This is the Haber process. The condition, basically what happens in the Haber process, it's the production of ammonia. Okay, we react nitrogen with hydrogen to produce NH3. Okay, they use the catalyst, which is finely divided iron, and the conditions are 450 degrees Celsius and 200 atmospheric pressure. So the conditions are 200 atmospheric pressure and 450 degrees Celsius. What is the catalyst? We said finely divided iron, or in other words, iron. What does the catalyst do? It increases the rate, but it has no effect on the yield, right? We said it doesn't affect equilibrium, it only just makes it faster. Question 7. The two gases responsible for acid rain are obviously sulfur dioxide and nitrogen dioxide. These two, memorize them. Again, like ماش عارف شو قلكوا والله, it's just memorizing, guys. Ammonia is a basic gas. We took this in grade 8, grade 9. Ammonia is a base, NH3. It's a weak base. Ammonia NH3 can be dried using CaO. Again, memorize. And والله I don't know what to tell you other than memorize. يعني if you want, you can open the book, but the book will tell you the same thing. Okay? Ammonia, NH3, is used in the production of fertilizers. Okay, again, memorize. Okay, here. The industrial manufacture of, okay, the uses of nitrogen and ammonia. Okay, we use it to manufacture ammonia and to make fertilizers. Ammonia is a colorless gas. It is less dense than air and very soluble. It's very important in making fertilizers and explosives. Okay, bombs وهيك أشياء. Okay. Question 11. Okay. How do we get nitrogen? مش نحن to produce ammonia. To produce ammonia, we need some nitrogen. So here's what happens. So we take air. Okay. I'm gonna like write this down. You're gonna take air, and we're gonna compress it. Okay. Compress this air. When you compress it, you get CO2 as a solid, and you get water. I think you get. I have it written somewhere. H2O, solid. Okay. This obviously we know that air isn't just made out of carbon dioxide and water, and it's also gonna give you oxygen in liquid form. Yeah, it's gonna give you oxygen, not as a gas. It's gonna give you oxygen and nitrogen in liquid form. Okay, so basically just liquefied air. When you liquefy air, carbon dioxide and water is released as solids. Okay, how do you liquefy it? You compress it, so you squeeze air so much. Okay, plus oxygen plus N2. Okay, which is in liquid form. Nitrogen has a lower boiling point than oxygen, so if you do fractional distillation, nitrogen will go out, oxygen will stay here. That's pretty much it, yani. Like nitrogen goes out. So, what's the first step? The first step is to compress it, right? We want to liquefy the air. We compress it. When we compress it, what do we get? Water and carbon dioxide. After we get carbon dioxide and water, we do fractional distillation of our liquefied air. What's going to happen? Nitrogen will liquefy. Whatever, you're going to get nitrogen. Okay. And then when you get that nitrogen, you store it. 12, I think, at equilibrium. No. When again in a car engine, what are the two things? Okay, نحنا يعني we put a catalytic converter in a car engine, so they convert the polluting gases that we usually get from the car engine, carbon monoxide, nitrogen monoxide, CO and NO, okay, and they convert it into less harmful products. Okay, again, how they memorize them. Okay, sulfuric acid. Okay, I'm gonna go over the contact process really quickly. Okay, the contact process is the process of making sulfuric acid. Okay, how do we get the sulfuric acid? You get it. You start أول شيء by getting SO2. How do we get SO2? We talked about it. We said you burn sulfur in air. We burn sulfur in air to get SO2 gas, right? So you get this SO2 gas, but then we want H2SO4. So we're gonna end somehow with with four O's. Right now we're on 2, so we have to reach 3. How do we get SO3? Again, we just react it with more oxygen to get, this is reversible by the way, SO3. The optimum conditions for this, by the way, is T equals 450 and pressure equals 2.0 atmosphere. Okay, these are the optimum conditions you need to memorize. And we got SO3 and SO4. What you do is you take SO3 and react it with some already H2SO4 and you get H2SO7, which is otherwise referred to as oleum. Okay, that's not really important, but you get oleum, okay, which is a fuming acid, okay, it's like bubbles with cassia. So we don't want that, we want H2SO4. Okay, so what we're going to do is we're going to take this oleum, we're going to react it in water. When you react it with water, you get 2 H2SO4. طب وليد, why didn't you just add water to SO3? Won't you also get H2SO4? ما look, if you add water, it's going to start exploding and bubbling above our shoes. That's why we write H2SO4 to get oleum, and then we put that oleum inside water to get 2 H2SO4. So here, once you get the SO2, you want to react it with more oxygen to make it SO3. Okay, and this is a reversible reaction, so its temperature is 450, its pressure is 280 m, and the catalyst is important, V2O5, vanadium oxide. Okay, sulfuric trioxide is produced then dissolved 90 concentration fine. Oleum here. Okay. Okay, the SO3 is not dissolved in water because the reaction is highly exothermic and it makes acid. It starts bubbling acids. Oleum is transported and then added to water, blah, 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 blah. We said we add the oleum to water finally, and then you get 2H2SO4. So, sulfuric acid, how do we manufacture it? Using the contact process. After you react molten sulfur with air, what do we get? We said SO2, right? You get sulfur with air, you get SO2. This SO2 that's produced is mixed with more air to make a product. What did we say? What did we say when you reacted with more air? What do you get now? SO3, right? Under certain conditions of temperature and pressure. Product A is then dissolved in concentrated sulfuric acid to form product B. We know that product A, when you dissolve it in concentrated sulfuric acid, you get H2SO7, right? The SO3, when you dissolve it in sulfuric acid, H2SO4, we get H2SO7. In the final step, product B is dissolved in water to reach the final product, sulfuric acid. The below are chemical equations. SO2 plus O2 gets you product A. Hey, what do you want? You want product A, SO3. In the exam, she might get you the same exact question, but change it and put product B. You can change it. You can say you can write H2SO7. For the chemical formula, you can write H2SO7. If she asks what's the name, oleum. What are the conditions? We had 280 m and 450 degrees Celsius. The Haber process was 280 m, 450 degrees Celsius. What's the catalyst? Vanadium 5 oxide. Okay. Question 14. Okay, use Le Chatelier. Okay, equilibrium خلاص. Okay. If pressure is, why do I feel like I'm missing something? I don't know. I feel like I'm missing something. Okay, use Le Chatelier, blah, 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 pressure is increased by decreasing the volume. So we decrease the volume. That means we increased the total pressure. When you increase total pressure, where does it move? To less gaseous moles. Less gaseous moles. Okay, less gaseous moles. Here we have 1, 1, 1. No, 1, 1. Because carbon is a solid. 1, 1. So no change, no shift. We have 2, 2, 1. It goes to the less gaseous modes. Left, backward. 2, 1, 2. obviously goes to the left, so to the right. You have 1, 1, 1, 1. So we have 2, 2, no change. 15. Okay, choose the correct answers, blah, blah, blah. If you remove Cl2, and we're decreasing Cl2, to counteract, we have to increase Cl2. Where is Cl2? Here. We want to increase it, so what are we going to do? We're going to go backward. And if you want to go backward, what happens to SO2Cl2? Since we're going backward, this is going to decrease, right? If you add SO2, you're increasing SO2. To counteract it, the system decreases SO2. How do we decrease SO2? We want to move away from SO2. So we go to the right, we shift forward. If you shift forward, what's going to happen to SO2Cl2? It's going to increase. Okay, again, changing temperature. If temperature decreases, here temperature decreases temp. To counteract it, we increase temp. If we increase temp, that means we want an exo, right? قصدي شو? We want to increase. If you decrease temperature, yeah, you want exo if you want to increase the temperature. Let's see. Here, our reaction is endo. Am I tweaking? Yeah, I'm not tweaking. I just read it wrong. Oh, my brain started lagging. Let me repeat. This reaction here is endo, right? Even if they put it here, it doesn't mean the backward is endo. It means the whole thing. The forward reaction is endo because we're absorbing energy, right? This is endothermic. Temperature decreases. To counteract, we have to increase temperature. How do we increase temperature? We go exo. The forward, this reaction is endo. So أنا بدي exo. So what am I going to do? I'm going to go backwards. If I go backwards, what's going to happen to SO3? It's going to increase since I'm going backward. Okay. How about here? Temperature increases. To counteract it, we have to decrease temperature. If you want to decrease temperature, يعني بدنا endo, because endo makes it colder. Okay, this reaction here is exo. أنا بدي endo, so I'm going to go forward or backward. I want the opposite, so I'm going to go backward. Okay, what's going to happen? Concentration of CO2, it's going to decrease. So since we're going away from it. 17, I think it's memorizing. Hello? Oh no, equilibrium. Okay, what happens if you increase the pressure by adding an inert gas? Inert gas, يعني noble gas, يعني no change. Everything remains constant, nothing is affected. 18. Adding a catalyst. What happens? It's just attained faster, but the concentration remains constant, right? If it's a catalyst. 19. Okay, a gas is bubbled into KMNO4 solution. This is called like iron manganate or potassium manganate or something like this, and the solution becomes colorless. What gas is that? It's SO2. It's in the book, okay? Just know that you can test for SO2 if you bubble the gas and the thing becomes colorless. The two things, we have MnO4, which is like manganate. Mn stands for manganate or something, and Cr2O7, the chromium, whatever, chromium oxide, whatever, dichromate oxide, whatever, I don't care. Whenever there's SO2 with them, they become colorless. That's how it works. Okay. So they probably might ask you what might cause a change in color of dichromate ions to colorless. You say SO2. Okay, a lime scrubber is used to minimize the release of sulfur dioxide. Lime scrubber, they put it in like factories وهيك أشياء, so sulfur dioxide is not released in the atmosphere to reduce acid rain, because sulfur dioxide and nitrogen dioxide, they both cause acid rain. When few drops of acidified barium chloride are added to a salt solution, the formation of a white precipitate of barium sulfate verifies the presence of sulfate ions. So in the book, how they say is they added barium chloride, BaCl2 or BaCl, I don't know what it was, and barium nitrate, and what they got is a white precipitate that indicates the presence of barium sulfate. It's a way to test for sulfate. I'll show you. Give me a sec. Sulfate should be sulfate ions here. Yeah, add a few drops of acidified. Oh, yeah, go back. Of acidified barium chloride or nitrate, BaCl2 or BaNO3, whatever, to a small volume of the salt. The formation of white precipitate of barium sulfate verifies the presence of sulfate ions. So if you want to test if something has sulfate, you add BaCl2 or BaNO3, and if you get a white precipitate, bam, That's barium sulfate. That means there's sulfate inside of it. Okay. Few drops of NaOH are added to an unknown solution. X. A pungent smell is released that turns a red litmus paper blue. Blue. Blue يعني base. Oh, what is this around? Base. Blue يعني base. Oh, ammonium is a base, but it's a weak base. But it's still a base. Okay? So, solution X is ammonium. Thank you so much for watching. Goodbye. Good luck.